Topic 6: Arithmetic Series and Geometric Series. In this video, we will go to Subtopic 6.2 Geometric Series. At the end of the lesson, all of you are able to identify a geometric series and determine the nth term of a series. First, we look at the definition of geometric series. A geometric sequence is a set of numbers obtained by multiplying the previous non-zero term with a fixed real number called the common ratio. Let A be the first term and R is a common ratio of a geometric series, then the first term will be A, the second term AR, third term is AR square, and so on. For example, I give you the sequence 2, 6, 18, 54, and so on. Formula for the nth term, Tn. Let A be the first term. Then to get the next term is the previous term multiplied by common ratio. Therefore, T2 we get AR. Look at T3. To get T3 is the previous term AR multiplied by R, then we get AR square. So, the general formula for Tn is AR to the power of n minus 1. Note that to get R is T2 divided by T1, R can be determined by using T3 divided by T2. Therefore, to get R is Tn over Tn minus 1. For example, let A equal to 3 and R equal to 2. Therefore, if I list the first three terms, I will get T1 equal to 3, T2 equal to 3 times 2, and I get 6, and T3 is 6 times 2, I get 12. Example 13. Find the 8th term and the nth term of the geometric sequence 2, negative 1, 1 over 2, negative 1 over 4, 1 over 8. So, first of all, we need to determine the first term, and we know that A is equal to 2. How to get R, or common ratio? R we can get by finding the ratio between T2 and T1. Therefore, R is equal to negative 1 over 2. To get the 8th term, or T8, is 2 times negative 1 over 2 to the power of 7. How we get this one? Tn is equal to AR to the power of n minus 1. 2 times negative 1 over 2 to the power of 8 minus 1. Calculate and we get T8 equal to negative 1 over 64. Next, we need to find the nth term. The formula of Tn is AR to the power of n minus 1. So we substitute the value of A and R. Then we have to simplify this expression. This one, you can use the properties of indices that we have learned in the first chapter, which is A to the power of x plus y. We can change into A to the power of x times A to the power of y. So what we will get is 2 times negative 1 over 2 to the power of n times negative 1 over 2 to the power of negative 1. And negative 1 over 2 to the power of negative 1 is the same as negative 2. Therefore, simplify this one. 2 times negative 2 and we get the expression of Tn is -4 times -1/2 to the power of n. Example 14. The second term of a geometric sequence is 3/4 and the fifth term is 6. Find the first term and common ratio, hence determine the seventh term. So, the information that we have here is second term is 3/4, means that T2 equal to 3/4 and the fifth term is 6, T5 equal to 6. So take out the formula for T2, we get AR equal to 3/4. Let this one become your first equation. And then we have T5 equal to 6. And the formula for T5 is AR to the power of 4 equal to 6. And we need to solve this equation to get the first term and common ratio. Let's say equation 2 we divide by equation 1. So what we have here, AR to the power of 4 from the second equation divide with AR equal to 6 over 3/4. And you can see that we can simplify A. And finally we get R to the power of 3 equal to 8. Cube root of 8 we get R equal to 2. So we have our common ratio. From the common ratio that we have before, we can find the first term. Let's say I choose the first equation. So I have AR equal to 3/4. Substitute R with 2 and simplify, we get A equal to 3/8. Next, the question asks to find T7. Just substitute into the formula of Tn. Tn equal to AR to the power of n minus 1. And substitute all the values of A and R. Finally, we get T7 equal to 24. Example 15. The nth term of a sequence is given by Tn equal to 2/5 to the power of n minus 1. Show that the sequence is a geometric sequence. This is what we have here. And now, to show that it is a geometric sequence, we need to find the value of R by using this formula and show that the answer that we get is a constant. So substitute. The problem is how to get Tn minus 1. By comparison, you can see that we just replace n with n minus 1. Simplify. By using the properties of indices, if we have a to the power of x plus y, we can change into a to the power of x times a to the power of y. And now we can cancel out 2/5 to the power of n. And we get 2/5, which is a constant. It's proof that the sequence is a geometric sequence. We're still in the example 15. The next question is, what term of the sequence is 512/1953125? The question needs us to find the n. This is the formula of Tn that we have before. So in the question, we know that Tn equal to 512/1953125. By comparison, this is what we have. So to solve this problem, log both sides to get the value of n. And finally, we get n equal to 10. This is the end of the lesson. All of you should be able to identify a geometric series and determine the nth term of a series. See you soon.